Hi guys, and welcome to another session of Connor's Mathland. Today we'll be talking about geometric and arithmetic sequences. First, let's start with this basic definition. What is an arithmetic and geometric sequence? Well, an arithmetic sequence is a sequence where any two consecutive terms always have the same difference, which we denote as D. Well, a geometric sequence is a sequence where any two consecutive terms have the same ratio, or when we divide the next term by this term, we always get the same number, which we call R. So in math tests, when you see the letters D and R, know that they are actually the common difference and the common ratio respectively, instead of just some random variables that your teacher decided to assign you. Well, how can we express these algebraically? If we let an arithmetic sequence have terms a1, a2, a3, an, this means that a2 minus a1 is equal to a3 minus a2 is equal to an minus 1, and is all equal to D. Which leads us to our first important formula for arithmetic sequences. If a2 minus a1 is equal to D, what would an minus a1 be equal to? What we can do here is we can simply add each of these together. So a2 minus a1 plus a3 minus a2 plus an minus 1. And then we'll see that a2 cancels with a2, a3 cancels with a3, and an minus 1 cancels with an minus 1. So an minus a1 is simply equal to n minus 1 multiplied by d. Why is it n minus 1? Because there are n minus 1 terms here, from a1 to a2 to a3 all the way to an minus 1. This also makes a lot of sense in a common sense way. Why? Because when we subtract an by a1, we simply get n minus 1 of the differences. When we rearrange this, we get the most important formula that you ever need to know of arithmetic sequences, which is an is equal to a1 plus n minus 1 times d. We can do the same thing for geometric sequences. Expressing this algebraically, we get that G, if G1, G2, G3, etc. to Gn is a geometric sequence, we get that G2 over G1 is equal to G3 over G2 is equal to Gn over Gn minus 1, which is always equal to R. Well, if we want to find Gn over G1, we can just simply multiply G2 over G1 times G3 over G2 times G4 over G3 times times Gn over Gn minus 1. And then we can see that all of these cancel out perfectly, where we're left with Gn over G1. But this is equivalent as saying R times R times R times R, but how many times? N minus 1 times. So Gn over G1 is also R to the n minus first 1 power. Rearranging this, we get that Gn is equal to R to the n minus 1 power multiplied by G1. So the nth term is always equal to the first term multiplied by R to the n minus 1 power. This also makes common sense. Why? Because to get the last term, we're simply taking the first term and multiplying by a series of R to get the last term. How many R's are there? There's not n, but there's n minus 1 because you have to progress and add n minus 1, or multiply n minus 1 times. Alright, so these two equations are extremely important when you want to find the nth term. However, another equation that is extremely important is when you want to find the sum of the first n terms in an arithmetic and or in a geometric series. So how do we do that? Well, we can also prove that but in a slightly different manner. In an arithmetic sequence, we have A1, A1 plus D, because A2 is equal to A1 plus D, A1 plus 2D, A1 plus 3D, and A1 plus N minus 1D. You can see that we're already using the formula that we derived last time. Well, we want to find the sum of A1 all the way to A1 plus N minus 1D. How would this help us? Well, by observing, we can see that the sum of A1 and of A1 plus N minus 1D, of A1 plus D and A1 plus N minus 2D, these sums are always the same. In other words, A1 plus A1 plus N minus 1D is equal to A1 plus D, second term, and the second to last term, which is A1 times N minus 2D which is also equal to A1 plus 2D plus A1 plus N minus 3D. Because in the end, we always get 2A1 plus N minus 1D. In here, we can simply remove the brackets and we get ND minus 2D, but we add that back by 1D, which also yields us 2A1 plus N minus 1D. How does this help us solve the problem of summing all of these together? Well, with this info, all we have to do now is simply calculate how many terms there are in this series and multiply this value by how many terms. But after that, we have to divide by 2 because we grouped 2 of each of the terms together. Why can we do that? Because if we have a common value from adding the first and last terms, second and second to last terms, we can simply think about we can simply equate that to having each term be 2A1 plus N minus 1D, but then simply divide by 2. So if we know that this has n terms, this gives us 2A1 plus N minus 1D times n over 2. This is one of the formulas of the sum of an arithmetic series. But the other formula, if we simplify a little, we get A1 plus A1 plus N minus 1D times n over 2, where if we add this part, we can simplify this to A1 plus AN times n over 2. So these are your two formulas for sum of an arithmetic series. You take the first term, the last term, add them together, multiply by the number of terms, and then divide by 2. Well, what is the sum of a geometric series? What is the formula for that? The formula for that is A1 times 1 minus r to the n over 1 minus r, where r is the common ratio, n is the number of terms, and A1, or sorry, I should write it as G1, is the first term in the series. Why is that? We'll create a proof in a later video that will be published soon. Thank you for watching Connor's Math Fan, and see you. Bye!